Here's our Greenlee A84885 hydraulic pipe bender. This one here is mounted horizontally. They could be mounted vertically as well, just to save space. This one here is bolted to this table. It's on wheels for mobility, so you can move around the shop. When bending 20 feet of pipe, it takes up a lot of room in the shop, so mounting these vertically could be the better option. This one here does have a measuring rod, so you can measure the ram. It's got the pump here. The pump, you have to open and close the valve for the ram to work, and our actuator, we're gonna have our on-off. It's got jog and continuous on that. Over here, we have our 881. It's a Greenlee as well. This one is designed for conduit, so thinner wall of pipe, just to eliminate the crushing. So we see the wiper die that we have with this. We'll have a little look at this at the end. We'll have to share the hydraulics with this pump over here at this machine. So with this machine, there's going to be a manual that comes with it, and in that manual there's a lot of charts. The manual starts off, looks like this here. It's a hydraulic bender. There's basically about 9 different charts in this book. First we're going to be looking at the ram travel. That's the measuring stick we looked at the side. Centerline radius of our tooling, and our deduct for a simple 90-degree bend. We'll look at that first. Over here we can see the other part of our book here. So the safety, so as we're operating the machine, we don't want to stand in front of it, we'll stand on the side. So just looking at the safety for that. Knowing your parts and pieces. So this here, just known as the shoe. We have our vertical pipe supports here at the end, and then just our main frame. You're going to need a different shoe for each size of pipe. This one's 1.25 inches. Doesn't say the centerline radius on this one. That'll be in the chart. And it's got the deduct on here for 2 3/8, so we'll be looking at that. These pipe supports on the side here, there is 4 sides to them. Kind of like a V-block on a press brake, where you're gonna have to select the correct one for the pipe. So this one here has got 1.25 inches, 1.5 inches, and 2 inch with this one. And it's gonna go as big as 5 inch on the other side. So we'll be inserting those. And with our frame, wanna make sure this support is going into the proper hole. So for this one here, it's got 3/4, 1 inch, 1.25 inches, 1.5 inches, and then bigger as you go out. So this one here, we'll slide it in, put it at the 1.25 inches. And for the dies here, if you do go to a bigger die, like these ones over here, 1.5 to 2 inch. We don't have anything smaller than 1.25 inches. They do make it, we just don't own it. All the way up to 4 inch. So the 4 inch is obviously a large shoe, and it's capable of bending that with steel. So over here, we just got a pin to hold the shoe in here, and it goes into another shoe to make it a little bigger on the inside. Just to hold and support that. With our pipe here, you want to make sure that you're bending on the mean of the weld seam here. So the weld seam, you can see it on the inside. When you go to the outside, you can see it just ground off there a little bit. These ones this is an electric resistance welded pipe here, grade B. And then over here, you're gonna see type E, grade B. It's an A53, that's ASTM, and this one will bend just fine. As soon as you go to, it's the same type E, it's electric resistance, but grade A is not heat treated, whereas the grade B is heat treated, and it's heat treated up to 500-600 degrees and then cooled. So this pipe is heat treated. This one is not. And you can see what happens when you go to bend a non-heat treated pipe. It's just too strong and it kinks. This is the same pipe here that I heat treated. So heated it up, like I said, about 500-600 degrees, not very hot. And then let it completely cool. As soon as it's cold, then you can bend it. You do not have to bend these hot. And when it comes to the aluminum, you want to make sure you're using a 6063, because then this will bend just fine. I don't have an example of 6061, but a 6061 would be the same as this grade A pipe. It would kink. It's not going to work. So the aluminum you could heat treat as well, just by heating up and cooling. Just don't overheat when you're heat treating the aluminum. Okay, so that just selecting your proper pipe is important. Back over here, again, just put a center line there. This one here, we're just going to go 16 and 16, just for our length of this pipe. So it's our minimum length that they have. We're going to use this angle iron to put a center line on the pipe. Always put a center line from one side of the pipe to the other. Then you're going to put that right into the center of the shoe, and the center line will be on top. So looking through this booklet here, know your terminologies, leg lengths. When you do two bends back to back, when you got two 90s, and also what is rise and what is stub. Stub and rise are the same thing. And we're just going to do a single shot bend here with this one. We're going to be using these charts here for the ram travel. So let's go ahead and put the pipe into the machine. And the minimum stub length here came off the chart there as well, so it is past the pipe supports. It is a little longer than necessary. So again, we're just gonna insert this into in between the shoe and the uprights, making sure you've got the correct one. And making sure you're on the center. Center and center. Okay, and we're going to hit the jog button here to jog it up. Again, you can make sure this is center. You can use other leveling devices or centering heads, and eyeballing to the ram just to make sure it's on center. Okay, so the measuring device, it comes in contact. It's just in contact now when it hits 1 inch on this measuring rod. And we're gonna have to go all the way up to 7 inches according to this chart over here. So let's go ahead and start bending. Flip it down for continuous. Off is the middle and up is jog. You can just leave that there for now. In this chart, it's a little worn out, it's a little hard to see. Basically, the minimum size here, 1 1/4 inch. The deduct is 2 3/8. Minimum stub length is 15, 13, 16. 90-degree bend with 1 1/4 inch, 7 inches. So it's just the chart there for that. We'll look at the deduct here in just a moment. Keep an eye on the rod. There's 4 inches. We got 3 more inches to go. The offsets on this side over here. Really hard to see. We'll look at the offsets after. We have 5 inches. There's 2 more inches to go. Also with this chart over here, the ram travel, it's got it not just for 90, but it's got it for 60, 45, 30, 15, and 10 for all the pipes. So some pretty common angles for your ram travel. So then you don't have to put a large sliding T-bevel on there. Okay, so we're at about 6.5. We'll slow down as we get going. Turn it off, I'll jog the last little bit. And this is the same with bending plate. You'd rather be a little bit over than a little bit under because it's easier to take the bend out than put the bend in. So from there, a little bit more. Let's undo the hydraulic pressure here. You'll see the hydraulics come back because we opened up the valve. From here, we'll just have to pull the one support. These have a locking lever on the bottoms of them. Let's pull the pin here. This comes off. The pipe does become stuck in the shoe just because it's trying to expand, so it gets a little tight in there. Just give it a little hit and hold on to the shoe. You can see all the paint or mill scale come off the pipe, and then there's our single shot of pipe right there. So when we're talking about our single shot of pipe, the duct that we're doing on there, it's going to come off of page 7, conduit size deduct. So this is the one shot here in the book. Also there's a chart on the centerline radius. This is a 7 1/4 centerline radius. This one shot here is 18 3/8 by 18 3/8 from the outside of the pipe to the outside of the pipe. To get the stretch out length of this pipe, all we need to do is deduct 2 3/8 off at each side. So 18 3/8 minus the 2 3/8, I get 16. So 16 inches here, 16 inches here, so 32 inches of pipe, and it'll come out perfectly at the ends. So this works out well. Deduct is fairly similar to gain, as it's another term that's used in that book there. The deduct is basically half the gain. So the gain would be outside dimensions added up and then subtracted from the actual length of the piece of material mathematically. So the charts are real easy, simple to do for that. There's your single shot bend. Over here we'll talk about number 4. Number 5, the offsets and the shrink. So here's an offset here. This is going to be on page 8 and 9. For this one here, we're using 1 1/4 pipe, 12 inches of offset, 45-degree angle. So in the book, you can find your constants tables on that. It's a trig table to get your length of the sloping side of the 12 by 12 45 triangle. So in the book, in the chart, they use 12 times 1.4. It's going to give the 16 and 15/16 for that length. So with this laid out, we used our minimum stub here of 15 and 13/16. That's just the minimum they had to save as much pipe as we could. So at the one side, we've got the 15/13. The overall length here, this is the obstruction. We have laid off from the obstruction. We came back 16 and 15/16, because if that was to come down flat, that would hit there, and then the last 15 and 13/16 at the end. So overall, we got 48 9/16, and when this is laid flat, when we bend it up, so we're going to bend one side, flip and bend the other side, it's going to come back and shrink. So this pipe obviously gets shorter as the 245s bend. There is a shrink table in the book. Go to the shrink table for the offset. In this one here, we got 12 inches on this one. Shrink table's 3/8, and you multiply those, you get 4.5. So this shrinks 4.5 inches. Now you can play with this however you like, how if you want to lay it off the obstruction or not. In the book, it shows it making the shrink come on the other side of the obstruction. But basically all it does is it pushes the pipe forward, and then it becomes closer to the obstruction, and then your distance is off the other side. The only problem is when you do push it all the way forward, this inside corner does hit the obstruction. So if you don't want it to hit, push it the other way, leave it away from the obstruction, and add the 4.5 inches for pipe for here. This is all very important, especially if you had another 90-degree bend coming off this end, because then you wouldn't have any trim to be dealing with. So that is your offset. There's a lot of different angles, a lot of different offsets, charts in the book that you can have with these, and trying to figure out the shrink. Okay, number 6, arc lengths. Now arc lengths are in the chart in the book there. You can use a chart if you like, or you can just use our standard diameter times pi times the angle divided by 360 will also give you the arc length. So instead of using the chart, you can just use some simple math. Those are for large radius bends. With the large radius bends, we're also going to have to do some bump bending, and we'll look at some ram travel angle for these as well. And we've already talked about the gain factor, but that's at the back of the book. So over here we got some large radius bends. This one here we just happen to go 40 centerline radius. This is in the back of the book, page 10, 11, and 12. And with this one here, with the 40 in the book, it tells you it's suggested amount of bends for the pipe with that radius. Now I found that there was too many bends for that size, so it went a little bit less. So this one here has actually got 3 spaces, 4 bends. Your end bends are always half your bends. So this one here is 30 for each one, 30, 60, 90. It's 90 degrees, but your ends are always half. So 15, so half of 30 is 15. This one here we also did so you had a fresh bend every single time in the machine, and the ram travel worked out well. So coming off the ram travel of the machine for a 15, 2 1/4, a 30 is 3 3/8. So that works off the machine well for ram travel. Obviously it's a little bit joggy, but that's what you get if you have a fresh bend every single time. Going over to this other pipe over here, it's the same. It's a 40-inch centerline radius, but we added some more bends to it, so we doubled up. So the amount of spaces on this one, we're gonna be 1, 2, 3, so we're 6 spaces. So we got twice the amount of spaces on this one, so we got seven bends. So we've doubled up, so instead of 30, we're 15, and we're 7.5 at the end. So instead of the 15 at the end. The ends are always your half bend when it's a tangent. The problem with bending something like this is you don't get a fresh bend every single time. And so as it slips in between the supports. So as with plate, you always start with the outside. So your outside bends first and you work your way to center. Myself, I like to jump from side to side and end up at center at the end. So I would bend my 2 tangents, then work in, and then work in from there. As I'm working in, I'm writing down my numbers for my ram travel, so it's the same on either side of my pipe. So it's just super important that you always work from the end to the center and you don't get locked out of the machine. That's always the problem with bump bending, is getting locked out of the machine and not be able to get it back into the machine again. Okay, so there's your bump bending. And this will be in the chart. Lots in the charts on this with the bump bending, and again the suggested bump bends are just suggested, and you can play around and do more of your own. This old one over here with the 6, would it really make much of a difference if I put more bends in? It is so smooth you probably wouldn't notice the difference. So obviously it's always quicker with less amount of bends. So more bends takes more time and doesn't always necessarily give you a smoother curve. The gain on here, again, the gain is the difference between the outside length of the pipe versus the actual length. So take your leg lengths minus your actual length and that is your gain. And that's the same as plate there as well. So as you're bending this in the machine, doing your 15s and your 30s, that works really good. But to double check those, to make sure they're accurate, just using yourself a big protractor, something like this one. This one's about 30 inches, 15-inch radius, and a nice big bevel set on this one here. So really easy just to make yourself something up there. A couple piece flat bar and a bolt with a wing nut, and it's quick, easy to check your pipes with that. So you're gonna need something big for this. So that finishes up our board, our 9 charts, working through the book. And there is another book, the 881, and we'll finish up just doing a bend on that. Let's head on over to this machine. I'll stick my gloves on here just because of the hydraulics. Make sure you have your rags. Close my pump lever there. Again, use a rag there so this doesn't drip all over the floor. You don't want to get any dust inside the hydraulics either. Make sure it's sealed tight. You don't want any leaking. Okay. This machine is going to work the same concept as the Hausfeld bender, where it's going to draw the piece of material in. So it's going to work from tangent of this die here and draw it through. So you're not working off a center. So with this pipe here, you'd have to mark a tangent and a tangent at the end. So you have to calculate your center line radius, do some math, line that up, tangent to the end of your shoe. It'll pull in, and it'll look to something like this when you're done. So you do have to mark your tangents on this pipe, whereas the one shot, you get to just do the center. It's a little bit more layout when you're dealing with this conduit pipe here. So this is all in, it's supported here. We've got our wiper die here at the back for support, so the pipe doesn't get crushed. Or if it was conduit crushes a lot easier. So we're gonna use the same pump, it's hooked up, and we'll just hit it to continuous. And we'll draw that through. So with the pressure, with the pump going forward, it puts pressure on here. It can only drive the one way. So as it starts to come up, it just starts to come over the one way. This die here does have a little lip to it. It does fit inside the shoe. So you can see that in here. Same with top and bottom there. Again, lots of support for that pipe. Getting a little tighter radius out of this one. Lots of other machines out there. This Greenlee is very popular. I know Rigid's got one. There's air operated that you can get. You can get different shoes that are coated so they're not scratching your aluminum pipe. There's a rod on this one. There is another manual with all the distances on that. I don't have this one on me right now, but that we're just going to eyeball this one that looks pretty close to 90, but just looking in the chart, and it's got the same numbers. The numbers are here off on the other side. Okay, from there we're just going to undo the valve. Just open it up. Just the ram comes back. Support, little pin here. Pin comes up. Same thing. Just give it a little hit. So die, these are just aluminum dies. Same sort of radius there. So there's the flip top 881. And that completes that. And there's our 884.